Hello everyone, welcome to this video. In this video, we are going to learn about Gaussian process regression using OpenMathAI. So, let's get started. What is Gaussian process regression? Gaussian process regression is a supervised machine learning algorithm used for regression problems. It predicts continuous numerical values while also estimating the uncertainty of its predictions. Unlike support vector regression, which learns a single prediction function, using support vectors, GPR models a relationship between data points using a probabilistic Gaussian process and a kernel function. This allows GPR to provide both accurate predictions and confidence intervals, making it especially effective for small and medium-sized datasets with smooth nonlinear relationships. GPR starts by computing the similarity between all training samples using a kernel function, such as the RBF kernel. It then builds a covariance matrix that describes how every training sample is related to the others. During prediction, the new input is compared with the training samples through the same kernel function, and GPR calculates both the predicted output and the confidence of that prediction. Imagine we want to predict the energy consumption of a building based on temperature, humidity, and atmospheric pressure. Instead of learning only a single prediction curve like SVR, GPR analyzes how similar the new operating conditions are to the training data and predicts the energy consumption while also indicating how confident it is in the prediction. This makes GPR particularly useful when the available data is limited or when prediction uncertainty is important. We will use an energy consumption prediction dataset for the Gaussian process regression model. This dataset contains 500 data samples. The input features include temperature, humidity, and atmospheric pressure, while the target output is energy consumption. During training, GPR learns a smooth nonlinear relationship between these environmental conditions and energy consumption. Once the model is trained, it can accurately predict energy consumption for unseen operating conditions while also providing a measure of prediction confidence. So, let's get started. OpenMathAI. In this demonstration, we use the energy consumption using GPR model. Click Create New Project. Enter the project name as Energy Prediction. Choose a folder location to save the project, then click Save. To import your dataset, either click Load Example Dataset or browse for Dataset to import your own CSV file. Once the dataset is loaded, verify that it contains all columns before proceeding to model training. Scroll down to view the first 10 rows of sample data. Click Continue to Configuration to proceed. Configure the dataset by specifying the input features and output target. There is also a feature called Ignore, which can be used for columns that should not participate in model training. Select the input and output columns manually, or use Smart Suggest for automatic recommendations. There is one more feature, Signal Diagnostics. There is 3 columns. First one is column. It's tell which features are in the dataset like inputs and outputs name. Second one is VIF. It tells how much correlation of the features. Third column is status, if it's okay, moderate, high, redundant, and constant. Review the selected configuration. Click Proceed to Model Design. Choose a model from the available machine learning models. OpenMathAI recommends suitable models and features based on the dataset. For this demonstration, select the GPR model. View the model overview, pros, cons, and real-world applications. Click Proceed to Training. You will see the selected model. Click Start Train Models. Review the training configuration. Test data split, which determines a percentage of data reserved for testing and validation. Review the model parameters and pre-processing settings. And also another feature is added that is train from scratch or continue from use model. If you train this model before you use that option. Modify the configuration if required. Click Start Training to begin the training process. After training is complete, review the following performance metrics. R-squared measures how well the model explains a variation in the output data. Range 0 to 1. MSE mean squared error measures the average squared difference between actual and predicted values. RMSE root mean squared error, the square root of MSE. Our MSE is expressed in the same units as the output variable, making it easier to interpret. Engine time. the time required for the generated model engine to execute and produce predictions. Lower engine time indicates faster model execution, which is important for embedded systems and real-time applications. Fit quality, an overall assessment of how well the model fits the dataset. It is generally derived from metrics such as R-squared, RMSE, and residual errors. Model accuracy. For regression models, accuracy is commonly estimated using the R-squared value. Example, R-squared equals 0.95, accuracy almost equal to 95%. Click Fit to Window, you will see three types. Fit to Window, comfortable, compact. Then the clear history if you click, that it will clear the history before its trained model. Another is deselect and select all trained models for export. Click View Curves. You will see the diagram of R-squared residuals and residuals diagram. Click Math and Code Preview. View the generated mathematical equation in source code. OpenMathAI provides expression of the data, detailed explanation of the expression, and an implementation code. Return to the results page and click Deploy Status. Click Export Model. Choose the required export format. Answer C, FMU 2.0, FMU 3.0, Verilog RTL, VHDL RTL, Python Bundle, ONNX Hub. You can choose any of these format and export. You can also download the free trial versions of OpenMathAI and Twin Simulate. Thank you. Stay tuned for more OpenMathAI demonstration.